lesson, 10.1, last chapter. Man, time flies when you're having fun. Okay, who wants to share something they learned in chapter 8? Matthew.
Sokotoa.
Good one! Sokotoa. Big idea. Alejandro.
Special right triangles.
Love that one. Our special right triangles are 45, 90, 30, 60, 90. Good ones. Let's go for one more. This is so fun. It's my favorite part of every new chapter. Brianna?
The difference between angle of elevation and depression.
Good one. Angle of elevation and depression. Okay, great. So, our last chapter is on circles. So, moving on from right triangles into circles. Today's pretty review for you, I guess. Pretty you'll be familiar with a lot of these terms. Okay. So let's go over some vocab first. Radius, when we're talking about a circle, is a segment that has one of its endpoints at the center of the circle and the other endpoint on the circle somewhere. So, looking at this circle on the right-hand side here, CF would be an example of a radius. The plural of radius, if I have one or more, is radii. We say radii instead of radiuses. All right, can somebody give me another radius? Alex? CE. Last one? CD. Thank you. CD. Those are all examples of radii on that circle. A chord is a segment with its endpoints somewhere on the circle, such as AB. Let me ask you this. Does DE qualify as a chord? Yes, its segments are on the circle. A special type of chord that goes through the center, such as DE, is a diameter. Okay, so a lot of that vocab we already know. One other thing, how we name or like notate circles, it's very similar to how we do triangles. We draw the shape with a center, and then you just call this circle, blank, whatever the center is. So this would be circle C, because the center is C. You can either write out circle or you can draw the circle. So if I look at this problem, when it says name the circle, you could call this circle, what's my center?
Q.
Q. Or you could literally write out circle Q. If you want to. Okay. Next, it asked me to name a radius. There are 4 possible answers for this. You can give me one. William. What did you say? Q?
Y.
QY? Good. Malin, give me one. Please. Any other radius?
XQ.
XQ? Walker?
QZ.
QZ? Dakota, last one? QW. Good. Any of those would be acceptable answers. Name a chord. 3 possible ones here. Lauren? WZ. Perfect. Thank you. Tyson?
WY.
WY or XZ? Name a diameter. 2 possible answers. Alex? WY. A chord that goes through the center. Or XZ. Okay, good on vocab? All right. All right, next thing, and again, you probably know this. in your own words, can someone explain to me, raise your hand for this, the relationship between the radius and the diameter of a circle? What's their relationship? Jessa. Good. The radius is always half of the diameter. Or if I said that the other way, the diameter is always double what the radius is. Okay? So here they call this the radius formula. So all you need to know is that this will hold true for every circle, that the radius is always going to be half of what the diameter is. Or you can do the diameter divided by 2. That's the same math, whatever makes more sense to you. And then we know the diameter is always double the radius. Okay. So here's a little example of this problem. It says if RT is 21 centimeters, if I'm looking at this circle V, RT is a diameter. What is the length of QV? What type of segment is QV? A radius. All right, so here's what I know. I know this length is 21, and I know my radius is always half of what my diameter is. So if my diameter is 21, 10 and a half, that means any radius on my circle is going to be 10 and a half. So QV would also be 10 and a half. You can do mixed number if you want. I prefer, when we're talking about like lengths of a segment, I prefer not improper fractions. 21 halves for a length is a little confusing. So 10.5 or 10 and a half centimeters for that. Okay. Any questions? Pretty simple so far. Yeah, it's going to be a lot of review. All right. This might be new for you. If we have more than one circle, specifically, we'll say 2 circles, like a pair of circles. The circles are congruent only if their radii is the same length. Okay, so think about that logically. The only way we'd have 2 of the exact same circles is if they had the same diameter or radius. So here in circle G, as long as that radius is the same length as in circle J, so if we know this, that radius is congruent to the other radius, bless you, then the circles we say are also congruent. So remember our notation for congruent looks like that. Okay, similar circles. We've talked about similar polygons where all the angles had to be congruent and then all the sides had to be proportional, but there's no like sides in a circle. So all circles are similar, every single one of them. They are just some type of like scale factor, like essentially proportional to each other. So like this circle might be double this circle. Okay. Circle X is similar to, that's the symbol, circle Y. All circles are similar. Okay, this might be new for you. Have you guys seen this vocab before? Concentric. Okay. That means 2 circles have the same center. And it also says they're coplanar, meaning they lie on the same plane, meaning I can't have like one circle right here and then another circle intersecting it like this way. Like if I were to have 2 planes and like intersect, those would not be considered concentric. They have to be on the same plane. All right, so you can see this example here. I'll outline these. So I have circle A here, and then I also have this big circle, which is also circle A. It has the same center. So to differentiate this, we'll say circle A with radius AB. And circle C with radius AC. are concentric. The prefix con for your English class. Anybody know what that means? I was like, we looked it up last class. It means with. So think with the same center. What's the same center? Okay. If we have two circles, I think a nice way to picture this is like two hula hoops. Here's basically the three possible ways they could intersect. If I had one hula hoop that was like way bigger than the other and I put the smaller one inside, those circles would never intersect, right? Or if I held them completely away from each other, they could possibly have no point of intersection. If I were to crisscross the hula hoops, they could intersect at 2 points, something like that or something like this. Or, have we talked about tangent in here? Not SOHCAHTOA tangent. Tangent meaning touching in one. No, that was my algebra class. Sorry, I get confused. If I were to just touch the hula hoops together, like if I were to just kiss them together at 1 point, they could technically just intersect at 1 point. Or if I were to put the smaller hula hoop inside and just touch it in the upper corner, they could also intersect at 1 point. So you have all three possible ways two circles can intersect. Okay, we're going to look at some intersecting circle problems next, but just for your visual and conceptual understanding, these would be the three ways circles could intersect. All right, so here we go. We have a circle that's intersecting in 2 points, two circles right there. Here's our information given. The diameter of circle X is 22 units. Here's circle X. I'll highlight it in blue. Now, I only see like a radius drawn here. So if the diameter is 22 units, what would the length of XZ be? Just 11. And we'll kind of just like label information as we go. You'll see why we need to know this length. In the end, we're going to figure out what XY is. So this distance right here, 11. Okay, circle Y. The diameter is 16 units, meaning the radius would be how long, folks? 8. Yep, half of that. So this length right here would be 8. All right. Next piece of information given to us is that WZ, this segment right here, is 5. All right, I'm going to give you 1 minute to figure out the length of X, Y. Don't say that out loud. Couple ways you can do it. It's really just like a bunch of segment addition postulate here. X, Y, 30 seconds. I'm seeing 7. I saw 9. I saw 29 or something. Okay, guesses?
14.
14, guess?
9.
9, guess? 14?
At 14.
14?
14.
14? 14?
At 22.
22! Okay. All right, Wyatt, how'd you get 14?
11 minus 5 plus 8.
Okay, so this whole segment's 11. Minus 5 is what, Wyatt? 6. This is 6. Plus this is 8. You get 14. Okay? What'd you get?
It's not 22.
No, it's not. 14's right. Units. Did somebody do it? Who else got 14? Somebody who got 14 do it a different way? Yes, Lillian.
I added 11 and then I subtracted 19. I subtracted 19 and 5.
Yes. So she did, 11 plus 8, and then subtract the part where they overlap. 14. Good. I'm so curious how you guys got 22 and 7. Okay. Let's try another one.
I had 14.
All right, the diameter of circle D, circle B, circle A are 4, 9, 18 inches respectively. Do you guys know what respectively means?
No.
In that order. So the diameter of D is 4. B is 9. A is 18. Okay, so let's kind of go through and label it. So circle D. Oh, what's this cute little circle right here? Okay, the diameter is 4. So the radius is 2. So this little segment right here is 2. Circle B, they tell us our diameter is 9. So this distance right here is 9. You could split it up if you want to figure out the radius, but that's what we know. Which makes sense because they tell us circle A, a lot going on here. Circle A has a diameter of 18. Meaning the radius is what? 9. And that matches my drawing, right? That's 9. Okay, I'm going to give you 30 seconds to find AC. This one is a little bit easier.
Oh, this.
Were you just memorizing answers from the last class? Oh, Ben. Can you write it? Try it. AC. Did you? Okay, guesses? Tyson?
7.
Brianna? Ben?
7.
7? Wyatt?
6.75.
Hilarious. Other people? Seven.
Bingo.
Look, you know this is 9 minus 2?
You get 22 walkers.
7.
Got 7.
Okay. Oh, basically. Oh no, 2 more things we gotta talk about. This you probably already know too. Circumference. In your own words, raise your hand. Who can tell me what circumference is? In your own words. Tyson.
Like perimeter for a circle.
Oh, I like that. Perimeter for a circle. What else? Someone add on to that? I like that. Basically, it's just like your distance around the circle, right? Yeah, distance around the circle. So, I guess my other class did this, and it didn't seem like a lot of them did this. Do you ever do that like little activity where you take like a string and like wrap it around the circle and like measure the length of the string in comparison with the radius to discover where the circumference comes from?
Never.
I never want to do that.
You want to do that? Oh, I was like, unfortunately, we don't do anything fun in this class, so we can't do it. But if you've done that before, you kind of see where the circumference formula comes from. It's kind of cool. Anybody know the formula for circumference that wasn't here last hour?
2 pi r.
2 pi r. Nice. That's one of them.
Wow.
Lord.
Now, good job, Lauren. 2 pi r, yes?
Diameter pi.
What'd you say?
Diameter pi.
Diameter pi. Why? Why are these the same? Brianna.
You just multiply the radius by 2 to give you the diameter. So
Double the radius is the diameter, right? So you can use either or. Now, I personally, if I know the diameter, I use this one. I just times it by pi. If I know the radius, I just double that and then times it by pi. I technically use that one. But you can use either or, you guys, whatever floats your boat, okay? All right, we're going to try a couple problems. Yeah, I use all the same jokes every hour. I don't have any other jokes. A series of crop circles was discovered in Alberta, Canada on September 4th, 1999, way before your time. The largest of the 3 circles has a radius of 30 feet. Find its circumference. So, if I know the radius, I use this one. You have to know these formulas. I will not give them to you because you're expected to know these on the ACT. 2 pi times 30 feet. You're going to need your calculator because you're going to need the pi button. Everybody know where the pi button is on your calculator? Okay, take 2 times pi times 30. Why am I getting a big long decimal?
pi is never ending.
Pi is never ending. What type of number is pi? What do we call those? Why? Because Josiah answered it right last.
No, it was Brady.
Who was it?
Brady.
Was it?
Irrational.
Irrational number. That's what we call those. Irrational numbers. Remember that? Numbers that never end or don't have a repeating pattern. Numbers we cannot write as fractions are called irrational. So you're going to get this big long decimal. You can just round it to 1 decimal place. That's a number you should have gotten. That's rounded. All right. Next question says, find the diameter and the radius of a circle to the nearest hundredth. Oh, shoot. I did not do that right. I did 10. Nearest hundredth. Okay, we'll fix it. If the circumference of the circle is 65.4 feet. I'm going to start with diameter. So I know the circumference is pi times diameter. This time I know what their circumference is. I know the circumference is 65.4. Think of this like an equation. On the right-hand side, I have pi times d. How would I solve this for d? Divide it by pi. Good. So in my calculator, I do 65.4 divided by my pi button. Round it to the nearest hundredth. We get 20.82. 2 ways you could find the radius. I could use my other formula of 2 pi r, but what would be easier? Just take half of that. We know the radius is half the diameter. So you already have this number in your calculator. Just divide it by 2. Hit divided by 2. Hit enter. Or times by half. 20.82. I got 10.41 feet on both of these. Circumference would also be feet. Because we're talking about like essentially perimeter or distance around. Feet squared would be if we were talking area. Okay. Good on that? Everybody know how to use their pi button? Next one. This one's a little different in the directions. It says, find the exact circumference of Circle K. So we just went on that spiel about how pi is irrational and how technically I rounded that circumference to 1 decimal place. That's not the exact circumference. We just rounded it. So when it says exact, that means they want you to leave pi in your answer and not actually use the pi button to get a decimal. Okay? So I'll show you that once we actually get to circumference. But if I look at my circle here, I'm like, all right, well, I know to calculate the circumference, I need to either know the diameter or the radius. I'm given neither of those. I'm given this chord length is 3 root 2. They're showing me here that this forms a right angle. What segments did I just trace here in green? Legs of the triangle. What about in when I'm talking about my circle? They're both radii, right? Those are both radii, so they have to be the same length. Those have to be congruent. Whatever the radii is, the radius is, those have to be congruent. Meaning, what about these two angles? So they're both what? 45, 45, 90, special right triangle. Wow, good thing we learned these last chapter. I have a 45, 45, 90, which means I have an L, L, L root 2. Okay, that blue segment's my hypotenuse. So L root 2 is 3 root 2, meaning L is what, folks? Just 3. Yep, let's cancel. L is 3. Meaning my radius is what? Also 3. That's what one of those legs are. So in this case, I'd probably use a 2 pi r formula because I know now the radius is 3. So to leave this exact, you just do 2 times 3, which is 6 pi units. There's no units given to me, so units. 6 pi is how we'd write that exact. Exact, write this down. Exact means no decimals. Okay, only one other thing we have to talk about. Okay, I don't think we've talked about this vocab before. A polygon is considered inscribed, and it can be inscribed of another shape or a circle if all of its vertices lie on the edge of that shape. Okay, so in this example, do we see how quadrilateral LMNP, see how all the vertices lie on circle K? So we could say quadrilateral oh gosh, I'm getting sloppy. LMNP is inscribed in circle K. So think inscribed inside. That's what that vocab word means. Okay, if I were to just quick look at the bottom of my notes here, that rectangle's inscribed that circle. The circle is inscribed in the square. Circumscribed means pretty much like the opposite. A shape can be circumscribed about a polygon if it contains all the vertices of the polygon. So here we could say circle K is circumscribed about quadrilateral LMNP. I feel like inscribed comes up a lot more. Okay, 2 more to go here. This says find the, there's that word exact again. Find the exact circumference of each circle by using the given inscribed or circumscribed polygon. Okay, so just talked about this. It's rectangles, inscribed. of this circle. Okay, so they want me to find the circumference of this blue circle. I don't know the radius and I don't know the diameter. All I know is that rectangle's side lengths, 8 by 16. If I were to draw a diagonal of the rectangle or a diameter of my circle, like so, can anybody see how we could find that length? Pythag, you betcha, Pythag. So we got 6 squared plus 8 squared. I'm going to call it D because it's my diameter. That's 100. What's the square root of 100, folks? 10. The diameter is 10. I'm not done. I'm asked to find the circumference. Circumference, when I know the diameter, is pi times the diameter. They want me to give it exact, so I'd write it as 10 pi inches. All right, last one. Here is my circle that they want me to find the circumference of. It's inscribed in this square, which has side lengths of 14. Ideas. Alejandro?
Wouldn't the diameter be 14? Because all sides are the same.
Exactly. This diameter will also be 14. Good. I feel like I saw a problem like this on the ACT prep stuff. So, exact circumference, 14 pi yards. One lesson down, 7 to go. Oh, 7.
He's out again. He was out for 5 minutes.